Now I want to find all asymptotes for this function. There's three types of asymptotes. There's first the horizontal asymptotes. There's the vertical asymptotes. And then there's the slant asymptotes. So to find the horizontal asymptotes, you want to find the behavior of the function when x is very, very large. To do that, you find the limit when x goes to plus infinity of f of x. So the limit when x goes to plus infinity of 6x squared plus 12 over 3x squared minus 14x minus 5. So when x is very, very large, the top is very, very large, so something large squared stays large. Something large squared also stays large, so this is something large divided by something large. To make sure which one is larger, or what's the proportion between the two, you divide by x squared, both at the top and at the bottom, because that's the highest degree factor, the highest degree power of x that shows at the bottom. So that's going to give you a 6 plus 12 over x squared over 3 minus 14 over x minus 5 over x squared. So that is now easy to see, because something very, very large, when you divide 12 by something very, very large, the answer is very, very small. Same here, same here. So the answer is then 6 plus 0 over 3 minus 0 minus 0. So that is 6 over 3, which is 2. So y equal to 2 is one of the horizontal asymptotes. You also need to check what happens when x is very, very large but negative. And a similar calculation is going to show the same thing. This could change if we had different degrees here, or if we had, say, an odd powered degree. Things could change slightly, but in this case, it doesn't change. The limits, both when x is very large and when x is very large and negative, are the same, so there's only one horizontal asymptote, and that's it. For the vertical asymptote, and now I'll save some space, move this over to the left. For the vertical asymptote, you have to check first what are the zeros of the denominator. So 3x squared minus 14x minus 5 equals 0. You have to solve that. And I like to use quadratic equation, just to be safe. And the quadratic equation is going to tell me that x equals minus b plus or minus the square root of b squared minus 4ac, all that divided by 2a. So x is 14 plus or minus, so 14 squared is 196, I think. I'll check on my calculator just to be sure. Right, is 196. And then minus plus minus, that's a plus. We have then 4 times 3 times 5. That's 60. So we're looking for the square root of 256, which I believe is 16. So that means x either equals to 30 over 6, which is 5, or minus 2 over 6, which is minus a third. And I'll check my 256 answer in a second, just to make sure I'm not making a mistake. And it looks like everything checks. So these are the two x's, and these are then the candidates as to why, as to whether or not these are vertical asymptotes. These are candidates. I don't know for sure until I've checked the top as well. So what are the roots of the top? So this is the first check. The roots of the top are 6x squared plus 12 equals 0. 6x squared equals minus 12. X squared equals minus 2. So there's no real root. That would be like an imaginary number. So plus or minus square root 2i, or I squared 2. So there's no real root. If there were, and if the root coincided with either the 5 or the minus 1/3, I'd have to sort of factor it out and cancel. That way, I would not get a vertical asymptote there because the limit when x approaches that number would not be infinity. But in that case, x equals 5 and x equals minus 1/3 are vertical asymptotes. For slant asymptotes, there are none, and that's because you need the degree of the numerator to be 1 plus the degree of the denominator. So what you need really is to write f of x as some ax or mx plus b, and some other function. This is the slant asymptote. And this needs to tend to 0 when x goes to plus or minus infinity. And the only way for that to happen is for you to get one extra degree from this. So for this to go to 0, you need the degree of the top, or it doesn't have to approach 0 actually, but to approach a number could be 0. But it could be like 1, 2, or 3 as well. So the only way for that to happen if the degrees of these are equal, and then you get the extra degree from this. So the degree of this would have to be exactly 1 plus the degree of the bottom. So something like x cubed over x, or over x squared, or x to the 4th over x cubed, or something like that. That doesn't happen, so there's no slant asymptote in this.